Hello, today we are going to learn how to use EMU8086 emulator. Using EMU8086 emulator, we can execute the assembly language program based on 8086 microprocessor. To understand better, we are going to take one example of reversing a string. And this string, which the user inputs through the keyboard, will be reversed and the reverse string will be displayed onto the monitor. So this program is basically written with the two different components. One is the assembly directives and the second one is the DOS interrupts. So basically the DOS interrupts are used whenever we need to access the input device, that's a keyboard, or the output device, which is a monitor, or we want to access certain files through our programs. So for these purposes, we use the DOS interrupts commands. So in this example, we are learning DOS int21 commands. So let us start understanding this program. So in the beginning, we have declared the stack segment. So for which we have said stack 1 segment 32. So segment is the assembler directives which will tell the assembler that this is the beginning of the segment. And the name of the segment is stack 1. And since the stack is a read-write memory, so the memory size which we have allotted here is 32. So 32 bytes have been allocated to the stack 1. And then we have stack 1 end S, where end S tells the assembler that this is the end of the stack segment. So then we begin with another segment definition. So that's a data segment. So the name of the data segment is my data, and again here the segment keyword tells the assembler that this is the beginning of a segment. Now under this data segment or my data segment, we have declared now three variables. So the first variable is str1, which is representing string 1, second one is string 2, and the third one is nl, where NL stands for new line. So let us understand how we define the variable. For example, string 1. So string 1, we have defined byte, that is db, which says that string 1 is including all the elements of byte type. Then we have another parameter, that is 0dh. 0D stands for carriage return. Carriage return is nothing but the enter key that we press from the keyboard. And so when in the string we are saying 0dh is going to be denoted to specify any string. So what this will do is it will align the cursor in the beginning of the current line. Then we have another parameter called as 0AH. So 0AH is ASCII for the new line. So once this has been executed, then the cursor comes to the new line. And in the same line, we have also initialized its value to the string 1, and the value is enter the string colon dash, and then after that at the end we have the dollar sign. So dollar sign indicates that this is the end of the string. So in the similar manner, we have again declared the second variable called as string 2 db, which stands for defined byte, that is byte type of elements are going to be stored in string 2. 0d, which is for the carriage return or the enter key, which will take the cursor to the beginning of the current line. And then 0a is for the new line character. So the cursor will come now to the new line, and the value of string 2 is your reverse string is, and then space colon dash, and then after that we have again the dollar sign. So again here the dollar sign indicates it's a end of the string. Then we have the third variable NL, which stands for null new line, and again it is db 0dh and then 0ah. And since we do not have any data to be stored here, and it is simply for the creation of a new line, we have put a dollar, which again says it's a end of the string. So these three, after declaring these three variables in the data segment, then we end the data segment by writing my data ends. So end is again here tells the assembler that this is the end of my data segment. Then we begin with the code segment definition by writing code segment, where segment is a assembler directive which tells the assembler that this is the beginning of code segment. Under that we have the again the first line as assume. So assume assembler directive tells the assembler what are the names of various segments which have been given by the user. For example, assume CS colon code. So code is the name given by the user for the code segment. Then ds colon my data. So my data is a name given by the user to the data segment. And then ss colon stack 1, where stack 1 is the name given to the stack segment. Then we have the next instruction, move ax comma my data, and then move ds comma ax. So this is to initialize a data segment to the ds, that is a data segment register. And then we have the third instruction, lea dx comma str1. So LEA here stands for load effective address. This is the instruction of 8086 which will compute first the 16-bit effective address or the offset address of the variable string 1, and that will be assigned to the DX register. And then we have very important function. This is move age, 09h and followed by int21h. Now move age, 09. So this will make by doing age equal to 09, we will be able to output a particular string onto the output device, that is a monitor, and then executing the interrupt 21h. But for that, whatever string which has to be displayed onto the monitor, we need to have the effective address of that to be stored in DX register. So that is why we have taken string 1 effective address and copied that into DX register. So after we perform this, so what is there in the string 1? So in string 1 we have the message enter the string. So once we execute these three instructions, then the message enter the string will be displayed onto the screen. Then we have taken one count register CL, which will be in the beginning 0. So CL is basically going to store the number of characters that we enter for this string, that is string 1. So as soon as this message is being displayed on the screen, the user tends to enter the string. So the string will be entered character wise, and to allow the user to enter the string character wise, again we take here the help of one function called as h equal to 0, 1. So that's why we said move h equal to 0, 1 in 21. So h equal to 0, 1 will allow us to read a single character from the keyboard, and whatever character we type, this character will be echoed on the screen, or it will be displayed on the screen, and then we execute in 21h. So together these two instructions will allow us to read a single character from the keyboard by echoing the character on the screen. Now whatever character the user enters will be by default stored in AL register, which we copy into BL register. And then what we do is we push the content of BX register or say BL register onto the stack. So what are we doing? Whatever characters for the string 1 we are entering from the keyboard are getting now pushed or stored onto the stack. And as we have read now one character from the string 1, so we increment now the count of the characters, that is CL will be incremented. So as we are reading the characters for the string 1, we also try to compare whether we have reached the last character of the string. So the last character by default will be the enter key. So we type the string, and at the end of all the contents of the string we press the enter key. So we want to check whether the user has pressed the enter key. So that is why we compare here AL with 0D, where 0D was our return carriage or enter key. So what AL has? AL is having the character that the user has entered from the keyboard. So if this character is equal to the enter key, then what we do? We go to the another label called as display 1. But if the character which we have entered to the keyboard is not equal to the enter key, then we again go back and we try to read the second character. So we keep reading the character. The character will be stored in the AL register, from where it will be stored copied back into BL register, and then we push the character onto the stack. And as we keep reading the characters from the keyboard, we keep on increasing the count of the characters, that is the CL will be incremented, and then the loop will be terminated when we press the enter key or we reach the end of the string. So once we reach the end of the string, then the control will come to this label, that is display 1. So by this time what we have done is we have entered one string by entering the number of characters and then pressing the enter key, and as we were entering the characters we have also stored those characters onto the stack. So we want to now display the string in the reverse way. So what logic we have used here is we will be now popping all the contents of the stack in the reverse way, because stack works as last in first out. So the last character that we have saved will be now popped first, and in this manner we will be now able to display the string in the reverse manner. So now for that what do is we again take now the help of h equal to 09 function. So what h equal to 09 will do, it will enable us to display the string onto the monitor. Which string we want to display first is string 2. So string 2 is nothing but a message that your reverse string is. So after displaying this message, we'll be then displaying the actual content of a string 1 in the reverse order. So for that what we do is we again load effective address of string 2 into the DX register, and then we call this function and the interrupt where your reverse string is will be now displayed onto the monitor. So after displaying the message, we are now supposed to display the string in the reverse order by displaying all the characters in the reverse order. So for that, what we do is we are also displaying the NL string. So NL was our new line. So the cursor will now come to the new line. So for that, we again take the effective address of NL into DX and then we print it on the screen. So now in this loop, we are actually going to print all the characters onto the monitor in the reverse order. So for that, where is our string now? Our string is in the stack, and then we are popping all the characters in the reverse way because stack works in the last in first out or first in last out manner. So here once we pop for the first time, the last character is going to be popped into the BX register, and from the BL we are copying it into a DL register. Why only in the DL register? Because we are going to use h equal to 02 function here. So what h equal to 02 will do? It will display now a single character onto the screen. But whatever character we need to display on the screen has to be stored in the DL register only, and that is a reason we are copying BL content into DL, that is the character that we want to display on the screen, and then we call this function move h equal to 02 int 21h, and then we again now call for the loop. So what the loop instruction is going to do, it will decrement the count register, let's say CL or CX by 1, check if it has become 0. If it has not become 0, then it will again take the control to the assigned label. So what we do is we now pop the second last character into BL register. From BL we copy it into DL, and now using h equal to 02 in 21h, the second last character will be now displayed on the screen, and we keep doing this till CL becomes 0. That is, all the characters are now printed on the screen in the reverse order. So this is going to be the end of our operation. So here we say code ends. So end is again here will tell the assembler that this is the end of the core segment, and then this is the end of the entire program, and then we can say halt. So let us now understand how to now execute this program. So here we have a emulate tab, so we can just click on the emulate tab. So here we can see that the different registers of 8086 like AX, BX, CX, DS, DX, CS, IP, SS, SP, BP, SI, DI, DS, ES. So as we now execute the code, the registers can be changing its values as they are being used in the program. So now in order to execute the program, we can click on this run. So here we get now this screen. So here the first message that we had displayed is str1, which was equal to enter the string. So here we will enter the string. So when I press now the first character M, I'm reading now this character in L register, and as I'm reading in L, I'm also pushing this right onto the stack. So M has now been pushed onto the stack. Then the second character O, so I'm reading it again in the L. From L again I am pushing back to the stack. So I keep on entering the characters, and when I reach now the end of the character, I need to press enter key, because this enter key is going to be checked, compared in the loop. That is, we have one instruction called as compare L with 0D. So L is going to read your characters, and if this character is equal to enter key, which is 0DH, then we stop reading all the characters. So the processor understands that this is the end of the string that the user has given from the keyboard. So now we press enter. So when we press enter key, the program has been now executed and it says that the emulator is halted. So when we press OK, we can again go back to the screen and we can see that our string 2 message, that is your reverse string is, has been now displayed, and after that, below that, the actual string contents are displayed in the reverse manner. So why the actual string has come into the next line? Because after displaying your reverse string is, that is string 2, we have also displayed NL, which is for the new line. So that's why the cursor has come to the new line, and here we are now going to print the given string in the reverse order. So this is how we can use EMU8086 Simulator to perform all the programs based on 8086 which are written with the help of maybe in21 DOS interrupts and also with the help of the assembly directives. Thank you.